In section 2.8, we will be discussing the algebra of functions, also known as operation on functions and function composition. So, first of all, you need to take note of what these types of notations mean for the four different operations on functions. The addition of functions, the subtraction of functions, the multiplication and division of functions. What you need to know is that if you are faced with f plus g or f plus g evaluated at some quantity x, you need to first rewrite that as f of x plus g of x. F minus g, pretty intuitive here, that's going to be f of x minus g of x. F times g, well, you're going to multiply. Note the dot for multiplication. That symbol that we're going to talk about for composition here in just a few minutes, it is sometimes confused with multiplication. So this is the multiplication with just the dot here, okay? And f divided by g of x means f of x over g of x. Now, you know, in the denominator of a fraction, we can't have 0. And so if that does occur, we will restrict the domain to exclude the values of x that make the denominator of our fraction 0. Okay? So one way that we're going to see how we use this, or one way we have used this before, is that the profit function is equal to the revenue minus cost function. That is an example of the subtraction of functions. Okay. On example 1, it says find f plus g of x and identify the graph of f plus g. Okay. If f of x is x squared and they want us to find f plus g, y'all need to know that that's understood to be f plus g at x. And remember from the box above, that means f of x added to g of x. Okay? Well, if f of x is x squared, f plus g is going to be f of x plus the g of x function. So g of x is equal to 3. So f plus g, if we want to simply write it like that, is the new function x squared plus 3. Okay, and so what we're going to do is we're going to look over here at our four choices, A, B, C, or D, and pick out what would the graph of this function, x squared plus 3, be. And it is going to be C, because we know the graph of x squared, and the plus 3 just means it's going to be translated up 3 units, and that corresponds to choice C. B and D were off the table because those are absolute value functions. In example 2, they're going to give us some functions. Let me do a little bit of color coding here. F of x is negative 2x. G of x is the absolute value of x plus 4. And h of x is 1 over x minus 3. So on number 10, if they want us to calculate g minus h evaluated at 2, I'm going to first rewrite that as g at 2, and the operation is to subtract from that h evaluated at 2. Okay? Now we're going to then compute the green term and the red term separately. And so if we come over here to calculate g at 2, we know that that means to go to our g function and replace x with 2. And so we have the absolute value of 6, which is 6. And so I'm going to put that in over here. I'm going to do 6 minus, what is h evaluated at 2? Well, to calculate h evaluated at 2, I'm going to come to my h function and replace the x with a 2. So that gives us 1 divided by negative 1, which is a negative 1. Now, when we apply the subtraction operation, 6 minus a negative 1 is the same thing as 6 plus 1, so our answer here is 7. For number 12, h times g evaluated at 4. We're going to rewrite that as the box directed, the purple box above, or I guess it's on the previous page now. H evaluated at 4 times g evaluated at 4. So now we got some new things to calculate. H at 4 and g at 4. So when we're calculating h at 4, that's going to be 1 over 4 minus 3, which is just going to be 1. We're going to be multiplying 1 by g evaluated at 4 is the absolute value of 4 plus 4. Absolute value of 8 is 8. So 1 times 8 is 8. We get 8 for our answer. Okay? Now, hey, we don't even get to use the f function. Poor little f of x equals negative 2x. He's being all ignored. Poor little guy. But anyway, for 18, we're now going to do h divided by g evaluated at a negative 4. So h divided by g. Both of those evaluated at a negative 4 will yield, let's see, maybe we can just edit a little bit. H evaluated at a negative 4 is 1 over negative 4 minus 3. That's going to come out to be negative 1/7, right? Because that's negative 7 down there now, okay? And g evaluated at a negative 4 is absolute value of negative 4 plus 4. Ooh, well, that's going to be the absolute value of 0, which is 0. And anytime we get 0 in the denominator of a fraction, our division problem here is going to be undefined. I guess I should say the quotient to that division problem is undefined. Can't have 0 in the denominator. That's the reason.